Hi guys, I am back again shooting one more video for you guys for Thursday the 23rd, and I will be here on Friday. Baby's doing well, mama's doing well, and everything's good. Just coming home to make some stuff for you guys today. Just to remind you, I will be at parent-teacher interviews to meet your parents or talk to you if you come with your parents or guardians. So I will be there tonight at parent teachers, just to clarify. So hopefully everything's going well with slope, rate of change. Today we're talking about first differences. So what we're looking at is, given a relation, basically given a table of values with a bunch of ordered pairs, and now again, almost out of ink, we'll manage for today, but given a set of ordered pairs like this, we're going to graph these. We're going to see if the relationship between those x and y variables are linear or nonlinear. We're going to talk about how we can visualize that with a graph and from calculating what we call the first differences. So first of all, before I even show you guys what first differences are, when they are constant, and we'll explain what these are in a second, the first differences, we say that a relation is linear. You can probably guess, graphing this type of relation, graphing a linear relationship, just looking at the prefix line, when you graph a linear relation, this would result in a straight line. So you guys have a couple examples there. I want you to pause the video, plot all of those points. So for example, we're plotting the point -2, 1 from this table, the point -1, 3. Plot all of those points for both, and then just quickly think about which one would you say is linear, gives a straight line graph, which one would you say is non-linear, does not produce a straight line graph. So pause the video, plot your ordered pairs, and then when you come on back, I'll have these filled in. Connect the dots with a straight line, and then we'll go over how to calculate first differences together. So I'm going to pause on my end right now and do those. You pause as well and try graphing those sets of ordered pairs. Okay guys, so I've graphed each of those sets of ordered pairs, and what we get with the first graph, we get a smooth straight line, we get a linear relation because the graph is of a straight line. Makes sense. And just a small note, I've connected my dots with a smooth line and added these arrows like so, just to indicate that if I were to continue this pattern, it would go on forever in the right direction, forever in the left direction. When we graphed the ordered pairs from the second one, what we get is this curve that goes down to the origin and then back up again. And again, I added those arrows to indicate that if we continue this pattern, it would just keep shooting up and up and up. And we call this kind of relationship a non-linear relationship. That's a very broad term. Any relation that's not linear, i.e. has like a curve in it, is nonlinear. And as you guys go through grade 10 and grade 11, grade 12, you will learn about more and more different types of nonlinear graphs, starting next year in grade 10 even. But we are focusing on linear relations. Now, it's easy to tell whether a relation is linear by making a graph, but if we were just to use our table of values, I'm going to show you guys how we can calculate first differences to see if a relation is equal, or to see if a relation is linear. So the first differences, all they mean is, as you increase your y values, what are we going up by each time? Let's look at the y values. 1 to 3 to 5 to 7 to 9 to 11. What are we increasing by? From 1 to 3, we're increasing by 2. From 3 to 5, we're increasing by 2. 5 to 7, 7 to 9, and from 9 to 11. For each of those, we are increasing by 2. And they're increasing by 2 every time. Now, and I'm going to add this little note here. The x column is increasing by a constant amount. X is increasing by a constant amount. So think about it in terms of rise and run. As the x value horizontally, we go up by 1 unit. We increase by 1 unit. The y values increase by 2 units. Over 1, up 2. Over 1, up 2. Over 1, up 2. Over 1, up 2. So this pattern, if the first differences are equal, we get a linear relationship. So that's what we meant by the original. If the first differences are constant, a relation is linear. And we can see that from our table of values. Again, connecting it back to slope. Over 1, up 2. Over 1, up 2. Now, when we look at our first differences for the second one, from 4 to 1, you need to think, okay, is that an increase or a decrease? And from 4 to 1 is a decrease by 3 units. From 1 to 0, that is a decrease of 1 unit. From 0 to 1 is an increase of 1 unit. From 1 to 4, increase of 3. And then from 4 to 9, increase of 5. And I often make these little, I call them little chevrons, just indicating, just relating those two values that I got the first differences from. Alternatively, if the numbers were bigger or you weren't exactly sure with your mental math, what you can do is to get these same first differences, you can start at the bottom and work your way back up. So what I mean by that is, to get this first difference, you could do 9 minus 4. 9 minus 4, which is 5. For the next one, 4 minus 1 is 3. 1 minus 0 is 1. 0 subtract 1 is negative 1. And 1 subtract 4 is negative 3. So two ways to find those differences. One, by just reasoning, okay, am I going up or down, and by how much? Two, you can systematically work your way up from the bottom using subtraction to get those first differences as well. Now, I want you guys to try a few on the back. I'm going to walk through two of them with you guys. I'll walk through A and B, calculating those first differences. And for each one of these, if you find that you have a linear relation, you're going to find the slope of that linear relation. And I'll show you guys how we can do that with our first example here. So let's look at A. This one is really easy because I can see that the y values are not changing. From 5 to 5, that is basically an increase of 0. From 5 to 5, an increase of 0. Here, the first differences are all 0. On the other side, as I go up the x values, we can see that here we're increasing by 1 each time. So because those x values increase by a constant amount and the first differences are constant, they're equal to 0, I know this is a linear relationship. And more than that, I can find the slope. Now I'll show you how we do that. So for A, because A is linear, our slope is rise over run. We can get that from our table, because think about it, guys. Every time we go from point to point, the y values increase by 0. That's the rise. the x values increase by 1. That's the run. And so we have rise over run, 0 over positive 1. The slope of the line that we would get from the table of values in A would be 0. If you were to graph that, it would be a straight line with a slope of 0. So when you guys do C, D, E, and F, if you find it's linear, you also will find the slope in the same way we just did. Now let's see if B is linear or nonlinear. And you might be able to tell like fairly quickly, almost even by looking at it. But it's important to be able to prove, communicate why something is linear or not linear. So let's use the subtraction method for this one. So working our way up. And again, this requires no mental math. We just do it. 8 minus 4, 4. 4 minus 2, 2. And actually right away, I can tell it's nonlinear because those two don't match up. But let's finish it off. 2 minus 1, 1 minus 0.5 is 0.5, and 0.5 minus 0.25 is 0.25. And these are the first differences. They are not constant, they are different. So this is non-linear. If we were to graph these points, it would have a curve to it, not a linear relation. So I want you guys to try C, D, E, and F. Give them a go. And I will do these as well. I'm going to pause the video right now and try these. And then I'd say in between 5 and 10 minutes, whenever most of you guys have a chance to do this, you can unpause the video and see how you did. All right, so talk to you guys in a moment. All right, guys, so taking these up, the relation in C is linear because the first differences are constant. We are going down 2 each time. Let's do the slope of this one now. So for the slope for C, because it is linear, using rise over run, we are going down 2 in the y values each time. We are increasing by 2. In the x values, again, the y values, the first differences give us the rise. The change in the x's give us the run. And simplifying this, we get a slope of -1. If you were to draw that line using those ordered pairs, you would get a line with a slope of -1. D is clearly not linear. The first differences are all different. And you have to excuse me, actually. This last one is +48. E is an interesting one. E is actually non-linear because the first differences are not constant. The first two are +9 because from -8 to 1 and from 1 to 10, you are increasing by 9 units. But then from 10 to 1, 1 to -8, -8 to -17, we are decreasing by 9 units, going down. They're different. Same number, different signs. This is a non-linear relation. And finally, F is linear. The first differences are constant. They are all 1. We are increasing by 1 in the y's each time. That will be our rise. Our run here, we are going up by a constant value of 0.25. So when we do this slope, how can we kind of express that? So using rise over run, we have 1 over 0.25. Now I'm going to show you guys a couple ways that we can write this kind of in more familiar terms. One, you could recognize that, okay, 0.25, if I multiply that by 4, it's going to be a whole number. So if I multiply the top and bottom by 4 and by 4, I get an equivalent fraction, 4 over 1, or just 4. The slope of that line is actually 4. Alternatively, if you just take 1 over 0.25, and I'll just go down to the bottom here, 1 divided by 0.25, you can just do that on your calculator and verify it gives you 4 as well. So the slope of that line represented by that table of values would be 4. So I hope you guys will, if you need to, pause the video, go back, ask a question about any example you want clarification on. You'll get a bit of text practice to work on. And tomorrow we'll see how you guys did with this week. We'll clear up any not messes, any things you want to ask about. And I look forward to seeing you guys tomorrow. Okay, and have a great rest of the day and work hard.